Hey, Global Impact students. This lesson is on more linear equations. We've already talked about slope-intercept forms, so here we're going to look at some other forms. Our learning target for the lesson is we want to be able to write an equation of a line given its slope and a point on the line. Some essential understanding for the lesson. The slopes of two lines in the same plane indicate how the lines are related. Also, linear functions can be represented by either the slope-intercept, point-slope, or standard form. One version can be transformed to another as needed. Some background knowledge that we need for this lesson. We know that we can compare lines with different slopes. For instance, a line with a slope of 6 is steeper than a line with a slope of 2. We will compare parallel and perpendicular lines. Important properties of these lines include parallel lines are equidistant from each other. Parallel lines have the same slope but different y-intercepts. The shortest distance between a point and a line is the perpendicular distance. That is the true distance between them. The slopes of perpendicular lines are negative reciprocals of each other. So like we said, the slopes of two lines in the same plane indicate how the lines are related. Given the slope and y-intercept, you can write the equation of a line in slope-intercept form. You can also write the equation of a line in point-slope form. So if you don't know the y-intercept, but you know some other point that's going to be on your line, we have this other form called point-slope form. The equation of a line in point-slope form through the point x1, y1, just some random point with slope m, is y minus y sub 1 equals m times the quantity x minus x sub 1. A lot of times we like to know where things come from, like where does this point-slope form come from? Well, we've already worked with the slope formula. Here's our slope formula. Okay, now if we substitute the general point, x and y, because our equation needs to have x and y in it, for x2 and y2 in the slope formula, we can rewrite the slope formula in point-slope form. So here we take out the y2 and the x2 and we just put in a variable, a general variable, y and x. And that's important. When you see subscripts in an equation or a formula, that's where you're going to be substituting values in. If you see just y and just x in a form, you're going to leave those as variables. So what we do is we're trying to develop this point-slope form. So the first thing that we would do is we would multiply both sides by the quantity x minus x sub 1, and that's what we see here in this line. Okay, and then what happens on the right side is that our x minus x sub 1's cancel, leaving y minus y sub 1, and on the left side we have m times the quantity x minus x sub 1. And if we just use the symmetric property of equality, we'll just flip that equation over. Y minus y sub 1 equals m times the quantity x minus x sub 1. So all this point-slope form is just a variation of the slope formula. So what is an equation of the line through 7, negative 1, with a slope of negative 3? Here's our point-slope form. Here's our x sub 1, our y sub 1, and our m. So let's substitute our values in. Okay, so that's what it looks like after we substitute our values in. You can see I've got a lot of parentheses going on, and you may ask, is that necessary? I think it's a great idea to do, because the one thing that has to happen here is when we substitute negative 1 in for y sub 1, the left side of this equation must be y plus 1. Here we don't have to worry about a sign situation. So our form, point-slope form, y plus 1 equals negative 3 times the quantity x minus 7. Okay, so example A down here, we're told a line passes through negative 5, 0 and 0, 7. What is an equation of the line in point-slope form? Well, the first thing you might do is, all right, we're going to use point-slope form, but we're not given a slope, but we have 2 points. Anytime we have 2 points, we can always calculate the slope. So let's do that. 7 minus 0 over 0 minus negative 5. That would equal 7 over 5. So the slope of our line is 7 over 5. So now we have a slope and we have 2 points. Let's just pick one of our points. And actually we could be strategic here. That's a y-intercept, isn't it? But let's go with point-slope form. So let's just use our other point. Negative 5, 0. So y minus 0 equals 7/5 times the quantity x minus -5. And just kind of clean this up a little bit. Y minus 0 is 0. 7/5 x plus 5. Right? So there's our equation in point-slope form. Not quite slope-intercept form, but we could distribute the 7/5 and get this into slope-intercept form, and that would look like this. 7/5 times 5 is 7. Part B says, what is another equation in point-slope form of the line through the points -5, 0, and 0, 7? So another equation, what's that mean? Well, what they're getting at here is we chose -5, 0 over here in our equation. Let's choose 0, 7. Both points are on the line, so we could use either point in our equation. So y minus 7 equals 7/5 times the quantity x minus 0. Right? Now let's just kind of clean this up a little bit just to show you what's going on here. Let's go ahead and take it into slope-intercept form. Add 7 to both sides. What do you notice? Either way, we calculate the slope, pick one of the 2 points, go with point-slope form, rewrite it in slope-intercept form, and we have the same equation. So the point there is that it doesn't matter which point you choose on the line. You're going to wind up with the same equation. When they're in point-slope form, here and here, they don't look the same. But if we clean them up a little bit, simplify them, and go ahead and take it into slope-intercept form, we do see that we have equivalent equations. All right, so let's talk about standard form of the linear equation. A standard form of a linear equation is capital AX plus capital BY equals capital C, where capital A, capital B, capital C are real numbers and A and B are not both 0. One or the other could be 0, but not both of them. So standard form, A, B, and C have to be real numbers. What is an equation of the line y equals 3/4 x minus 5 in standard form? And then it says use integer coefficients. Usually when we talk about standard form, the definition here says A, B, and C have to be real numbers. But usually when we're talking standard form, we have to have integer coefficients. Well, what does that mean? Well, that means that fraction, 3/4, we don't want that. Okay? So standard form you see is a little bit different. We want to wind up with x and y on the same side of the equation, and then a number, c, a constant, on the other side of the equal sign. So here we don't have y and x on the same side. So the first thing we're going to do is we're going to subtract -3/4 x to the other side of the equation. And then what we have to do is we have to recognize, okay, we have a fraction here. How do we clear a fraction? Since we only have one fraction, what we're going to do is we're going to multiply the entire equation by that denominator of 4. So when we do that, we wind up with this equation. -3/4 times 4 is -3. Okay. -3/4 times 4 is -3. Y times 4 is 4y. -5 times 4 is -20. Don't forget to multiply the constant on the other side of the equal sign. Okay, so this becomes we're using the distributive property here. And as long as we multiply both sides of the equation by 4, we don't change the value of the equation at all. So that's how we rewrite in standard form. Get x and y on the same side, clear any fractions. Okay, so here's a summary. We have 3 forms that we've looked at: slope-intercept form, point-slope form, standard form. I would make sure I have those in my notes. Now let's talk about how we use standard form. Standard form is nice because we can determine the intercepts of our graph of the equation, x and y intercepts. And the way this works is we say, okay, we're going to let x equals 0 to find the y-intercept. So we're trying to figure out where our line crosses the y-axis. And we're going to set x equal to 0 because no matter where we are on the y-axis, x is going to equal 0. So we use that fact in our equation. We substitute 0 in for x and solve for y. So we find that y is 3. Similarly, we want to set y equal to 0 to find the x-intercept because anywhere along the x-axis, wherever the line happens to cross, that x value, we know that y is 0. So we're going to use the fact that y equals 0 and solve for x. So here we have our two intercepts, 3 and 5. Y is 3, x is 5. So we put a dot on 3 on the y-axis, and we put a dot on 5 on the x-axis, and we need 2 points to draw a line. Draw our line through those intercepts, and you have your graph. Okay, so let's take a look at an application here of our different forms. The number of times a cricket chirps per minute depends on the temperature. The number of chirps in 2 seconds for 2 temperatures are shown at the bottom right, down here. What graph models the situation? Well, first we need to find the number of chirps per minute. Okay, number of chirps per minute, that right there. When you hear chirps per minute, what should pop into your head is slope. That's the slope of the line. And we need 2 different ordered pairs to do this. So when the temperature is 40 degrees Fahrenheit, we find we have 0 chirps. Okay. 93 degrees Fahrenheit, 240 chirps. No. When it's 40 degrees, we have 0 chirps. Okay. 93 degrees, we have 8 chirps. So let x equal the temperature in degrees Fahrenheit. Let y equal the number of times the cricket chirps. We're going to let x equal the temperature and y equal the chirps because the number of chirps depends on the temperature. So y is our dependent variable, x is our independent variable. So we have 2 ordered pairs here, 40, 0, 40 degrees, 0 chirps, 93 degrees, 240 chirps per minute. So we plot those 2 values here and here, and we draw a line between those 2. So what is an equation of the line in standard form? Well, standard form, let's start off with our slope. So this is going to be a little different variation of standard form. Get our slope formula. Start with point slope form because all we have is a slope and 2 points, neither of which is the y-intercept. Plug our values into the point slope form, simplify our equation, and then bring x and y onto the same side of the equation. There is our standard form. Okay? Now, one thing here is this 4.5, this is not an integer. Okay, 4.5 a decimal is not an integer. We don't have to have integers, so for this problem, it's okay to leave this as 4.5. Right? So there's our equation. Now, our part C, if the temperature is 70 degrees, how many times would a cricket be expected to chirp in 1 minute? This is where having an equation comes into play because we have 2 specific points of data for the situation. We use those 2 points of data to graph it, but what we need here, the whole key is getting this equation. If we can develop this equation, then we can answer any question like this for any temperature once we have the equation. So temperature is x, so let x equal 70, and then just substitute it into our equation and solve for y. And you'll see here, what the example shows is it's easier to use slope-intercept form. There's less calculation to do when you're evaluating. Remember, this is our function form. So we're letting x equal 70 and we're solving for y. This is where the function form, the slope-intercept form comes in handy when we have certain x values and we're trying to find y values. So if the temperature is 70 degrees, the cricket would be expected to chirp 135 times in 1 minute. Okay, and we didn't really do anything with parallel and perpendicular lines in the lesson here, but one thing that we need to remember is that the slopes of parallel lines are equal, and the slopes of perpendicular lines are negative reciprocals of one another. And the whole key here is that neither line can be vertical in both cases, although that's just to fit this definition. But we do know that 2 vertical lines, they're still parallel, but we just can't discuss their slopes because slopes are undefined, but they still will be parallel. A vertical line and a horizontal line will be perpendicular still, but we just can't discuss their slopes because the slope of a vertical line, again, is undefined. Have a good day, folks.